Welcome back everyone to our YouTube channel. Today we have a new topic to dive into, Apache Spark. If you're new to big data or looking to enhance your data processing skills, you're in the right place. In this beginner's guide, we'll break down Apache Spark, explain what it is, why is it essential, and how you can get started. So without further ado, let's get started. Let's start with what is Apache Spark. Apache Spark is a unified computing engine and a set of libraries for parallel data processing on computer clusters. Spark is the most actively developed open source engine for any developer or data scientist interested in big data. Spark supports multiple widely used programming languages such as Python, Java, Scala, and R, includes libraries for diverse tasks ranging from SQL to streaming, and runs anywhere from a laptop to a cluster of thousands of servers. Let's first understand the Apache Spark's philosophy. We'll break down the description of Apache Spark into three components. Unified. What do we mean by unified? Let's take an example. If you load data using a SQL query and then evaluate a machine learning model over it using Spark's ML library, the engine can combine these steps into one scan over the data. The combination of general APIs and high performance execution, no matter how you combine them, makes Spark a powerful platform for interactive and production applications. The next thing is computing engine. At the same time that Spark strives for unification, it carefully limits its scope to a computing engine. By this, we mean that Spark handles loading data from a storage system and performs computing on it and not act as a permanent storage. Spark's focus on computation makes it different from earlier big data software platforms such as Apache Hadoop. Data is expensive to move, so Spark focuses on performing computation over the data, no matter where it resides. The third component is libraries, which build on its design as a unified engine to provide a unified API for common data analysis tasks. Spark supports both standard libraries that ship with the engine as well as a wide array of external libraries published as third party packages by the open source communities. I hope dividing Spark into three components helped you understand better what Spark is and how it helps in processing the data. Now let's talk about the history of Apache Spark. Apache Spark began at UC Berkeley in 2009 as the Spark Research Project on Big Data Technologies. They shared their observations in the form of a research paper entitled Spark Cluster Computing with Working Sets. The AMP Labs company, which facilitated the starting of Apache Spark, contributed Spark to the Apache Software Foundation. The early AMP Lab team also launched a company, Databricks, to harden the project. Apache Spark community released Spark 1.0 in 2014 and Spark 2.0 in 2016 and continues to make regular releases, bringing in new features into the project. From technology companies like Uber and Netflix using Spark streaming and machine learning tools to institutions like NASA, CERN, and Broad Institute of MIT and Harvard applying Spark. Now let's talk about how we can run Spark. There are two recommended options for getting started with Apache Spark. One is downloading and installing Apache Spark on your laptop. As a prerequisite, you will need to install Java and Python. You can then directly install Spark using the pip install command. The other option is to run a web-based version in Databricks Community Edition, which is a free cloud environment for learning Apache Spark. The method is to launch a cluster in Databricks and run Spark directly there. You can refer to my video on Databricks to see how we can do that. So once we have installed Spark in our system, we can now talk about the Spark's toolkit. First, we have the low-level APIs called as the RDD APIs. RDD is a fundamental data structure in Spark's low-level API. It represents a distributed collection of data that can be processed in parallel. RDDs are fault tolerant and can be cached in memory for iterative processing. The second level is data frame APIs. The data frame API provides a higher level, more structured approach to working with data. It is designed for processing structured data like tables and support the use of SQL queries. The third component is libraries. Spark Streaming provides libraries for processing data in real time. It can be used with both RDDs as well as data frames. And there you have it, folks, a beginner's guide to Apache Spark. Whether you're installing Spark on your laptop or exploring it in the cloud with Databricks, you are now equipped to begin your journey with this powerful big data tool. If you found this video helpful, please give it a thumbs up, subscribe to our channel for more tech related tutorials, and hit the notification bell to stay updated with our latest content. If you have any questions or topic you'd like us to cover, feel free to leave them in the comment section below. Thank you for watching. Happy learning.